So this is kind of cool. So I made it so that there's a minimum size to everything, so that almost that baselines every glyph, um, which is kind of fascinating to check out. But so let's look at the space of food. So this is like 7,000 foods plotted, right, in the space of, and let's just go check because I'm not quite sure. Let's see what's being plotted. Oh, the wrong stuff. First of all, not what I want. This is what I'd last saved on. So manganese, phosphorus, and riboflavin, which I could give a shit about, really. So let's put in sodium in the X. Actually, I don't want sodium because it's already in the glyph. So what I want is kilocalories. So let's put on the Z-axis the kilocalories. So in the up direction, we'll spread out the stuff via kilocalories, and then maybe sodium. Let's see what would be interesting. Calcium, carbs. So as a function of, so yeah, that's a good one. Carbohydrates. So we'll do carbohydrates and calories. And I don't care about phosphorus. What else are we going to do? Let's do maybe have carbs. Not protein. We're plotting that on the actual thing. How about water? Water content of the food. That's a good one. Let's execute this sucker. Takes about 9 seconds. Oh, even quicker. How's that? 319 milliseconds plot. So it took about a third of a second to go and plot all that crap. Okay, and then so that's moving in the space of, wow, that's fascinating looking actually. There's some surface geometry. So we've got the Z direction as calories, the Y direction as water, and the carbs as X. Huh. That's fascinating. And then so the scale of each individual object looks, say we wanted to look at this one. Whoop! And so what do I have piped into the XYZ scale? So I have, let's look at the XYZ scales. So what am I piping in? I'm piping in vitamin C, sodium, and protein. So this is a model of vitamin C, sodium, and protein in a ring. And so you can see some are kind of like flattened in one direction versus the other. Huh. That's fascinating. Let's look from the top and zoom out a little bit at this space. So water content, sodium, and calories. And this is what you end up with spread out. And then individually, here's another 3 dimensions. So this is basically a 12-dimensional space plot. And that's what I was talking about, Chris. But this is just the start of it. You can imagine I could put more toroids and bars and other things and get hundreds and hundreds of dimensions per object, and then be able to fly around to it. Like, let's go to the low-calorie, high-water, low-sodium space. That's these objects. And then if you put an overlay on this, it would actually tell you what food that was. Yeah, that's pretty trippy.